have base station which covers a certain area, usually a small coverage area. And within that small area, we have number of users through which communication is established by air interface. So when a base station is covering a small area, so there are different techniques how to identify each user. So how this base station will identify each user? There is a technique called as multiple access technique. So multiple access technique is a method by which each user are uniquely identified by the base station. So there are different techniques. One such is FDMA, frequency division multiple access, wherein each user is uniquely identified by a different frequency. So here, this user, suppose if is allocated frequency F1, then another user will be allocated a different frequency F2. Like this, for this user, F3, F4, and F5, like this, different frequencies are being used, such that base station is uniquely able to identify each mobile users, or here it is called as mobile station. Another method is we can go for time division multiple access, where the frequency can be same for all the users, but they are allocated at different time slots. So this user having the same frequency by all the users, but the time slot allotted to him will be different. Similarly, this user may be allocated as time slot 2, and this may be time slot 3. So like this, by uniquely allocating the different time slots, each user information can be uniquely processed by the base station. Another method is CDMA, code division multiple access. So here again, since there is a common media between air interface between the mobile station and the base station, so there should be a different coding and decoding technique allocated to each user will be different, even though carrier frequency will be the same, but the different coding and decoding techniques are being used, such that the information is uniquely being processed by the base station, and further by the it will be sent to the switching center for further switching. So these are the different multiple access techniques, such that the user process is done separately by different techniques. But in GSM mobile communication system, it goes for both combination of frequency division multiple access and time division multiple access. So I hope you understood what is multiple access technique. So it is nothing but, since we have a common media for all the users for connecting to the base station, that is air interface, a common media for all. So to uniquely identify each user, we have a different techniques. So, but as far as GSM mobile communication is concerned, it goes for both combination of frequency division multiple access and time division. 915 megahertz, this band is used for uplink. Uplink means connecting them. So that means the frequency band used for transmitting from MS to base station, BTS, base transceiver station, which is called as uplink. The uplink frequencies are different, and the downlink frequencies used are different. So in the downlink means it is from BTS, base transceiver station, to mobile station. So here, why this is required? Because in our mobile communication or in any communication, basically we need to have a full duplex communication. That means both transmission and reception should be done simultaneously. To overcome the interference, we need to maintain a distance called as a duplex distance. That means trans and receive frequency should be separated by 45 megahertz. Suppose if the one particular user is transmitting at 890 megahertz, and he can only receive at 935 megahertz. So this difference between the trans and receive frequency here, which is here about 45 megahertz, is called as duplex distance. This is required to avoid the interference. And here we have another, because since we need to cover, or we need to have more number of users to be served, so there will be within this frequency band a number of channels or radio channels are generated, that is, which are separated by 200 kilohertz. Suppose one frequency used is 890 megahertz, then next another frequency carrier is at 890.2, 890.4. Similarly, here also in the downlink also, this band is divided into number of carriers which are separated by 200 kilohertz. So, and within each carrier, there will be a number of time slots. About 8 time slots are generated for use of the control channel as well as user information. Since I said the GSM works with FDMA and TDMA, I hope you understood what is the frequency band, what is uplink frequency and downlink frequency, and what is meant by duplex distance. Because if I'm transmitting at this any of these frequencies, I can only receive by this separation of 45 megahertz. So this is basically done to avoid the interference between the trans and receive. And here then there will be a number of RF channels that are generated, and that channels are separated by 200 kilohertz, such that more number of users can be served. Another band of that is used is 800. So in case of 800 megahertz band, we frequency spectrum, we in the uplink we have 1710 megahertz to 1785 megahertz, and in the downlink from base station to MS, the frequency band used is 1805 megahertz to 1880 megahertz. So here in this, the frequency trans frequency and receive frequencies are separated by 95 megahertz, and that is a duplex distance that is used in 800 megahertz. And the channel bandwidth, it is similar to the previous frequency band, that is 900 megahertz. Here also each channel, radio channel, is separated by 200 kilohertz. So that means here by this process, we are able to have both FDMA and TDMA system working in the GSM mobile communication system. So another important concept that is to be understood here is cellular concept. What is this cellular concept? Cellular concept. So now suppose consider we need to cover a certain area, service area. This is the service area, certain area to be covered for providing the mobile communication system. So now this whole area is divided into small areas, and they are all served by a particular base station. So here I have one base station which is covering this small area. Another base station is covering another small area. So like this, we can have more than one base station which will cover this whole area. Why we need to have such a small coverage area? So here basically we need to know that each base station is serving for more than one users. And similarly here also I can have more number of users are being given connectivity. But the main reason for dividing this is we cannot have a single base station which covers a large area. But since our mobile equipment or mobile station is a small handheld device, where the power that is generated by the mobile station is very less. So we need to, considering since it is a full duplex communication, even though I can transmit from base station at high power, but MS cannot transmit at high power since it has a small handheld device. So to take care of this full duplex communication, we will be dividing the whole area into small areas, and each base station can operate at different frequencies such that more number of users can be served. So now here, that's what the cellular concept says. We cannot have a large radio tower and a large service area cannot be achieved because we need to have a full duplex communication. Our mobile handset is having a limitation regarding power generation. And by this process, we can have only serve some few number of users by having a large service area by one single base station. So instead of doing this, to provide more number of users with the available frequencies and with the available power of the mobile handset, we need to go for small cells called as a cellular concept with the frequency reuse. So here frequency gets repeated. So the advantage of this cellular concept is, so low power handsets are sufficient, and I can achieve more number of users can be served by going in for with the available frequency band. More number of users can be served. Capacity is improved upon. But the drawback of this cellular concept is the cost of cell is high. The number of cells, because we need to have a tower and equipment and all these cost is involved here in setting up of the cells. And another problem here will be handoff between cells. When a user is moving from one cell area to another cell area, so then handing over from one base station to another base station, one BTS to another BTS is required. So the system should take care of this handing over process without fail or without any drops. So then another is all the time the network should monitor the user where is available, in which cell is available for extending the service. So that is incoming call or message to provide him. So it has to keep a track of the user availability. Thus location updation is very much required here. So then since we go for frequency reuse, we need what is being done is a group of cells are made use with the unique frequencies called as a cluster. Now here an example in this cluster size is n equal to 3. That means I have 3 cells with unique frequencies, and this group of cells, this is one cluster of size n equal to 3. And this cluster can be repeated. But here we can see this repetition means the frequency will be reused here. The whatever one have mentioned here, that is a one particular frequency. The same frequency, radio frequency, is repeated in the next cell at a certain distance. But since the cluster size, cluster means it is a group of cells operating in different frequencies. So if in the small size, what happens? There will be the distance between the two cells having the same frequency is very less, and due to which there will be an interference. So whatever interference will be taking place, and so that is the one of the drawback of going for cluster size small. Even though here the advantage is with this available small band of frequency, I can serve more number of users, but there will be an interference here. Then I can also go for cluster size n equal to 4. N equal to 4, here you can see I have one cluster, 1, 2, 3, 4. So this group of cells called as one cluster. So total 4 cells having unique frequencies used are made use, and this is called as one cluster of size n equal to 4. And this cluster can be repeated to serve that particular area. Again, here also, of course, the capacity is improved upon because I'll be having one more frequency I can use. But again, the distance between you can observe here, the distance between the two cells which are operating in the same frequencies are near only. It is there is a chances of co-channel interference. There will be an interference that will be taking place. So another optimal cluster size we can say is n equal to 7. N equal to 7 means this is a group of cells, 1, 2, 3, 4, 5, 6, 7. There are total 7 cells, and this is called as 7 cell cluster. And that means here in each cell, the different frequencies are being used uniquely. And these group of cells called as cluster size n equal to 7 can be again repeated here. You can see here there is another same cluster size n equal to 7 is repeated here. And similarly, I can have another cluster of size n equal to 7, and another cluster is being used here. So the advantage here is, of course, I need 7 different frequencies to make one cluster, and they are uniquely placed here. And of course, here, as you can compare with the cluster size n equal to 3 and n equal to 4, the distance between the two cells operating in the same frequencies is more here. And I can serve more number of users, but the carriers required will be more than the whatever we have seen so far, n equal to 3 and n equal to 4. So more number, 7 different frequencies are required here, but number of users that they are served are more here, and interference is also minimized. So that means we can need to go for a trade-off here. What is that? Trade-off is, so that means we need to go for a optimal size of the cluster. If I have a small cluster size, then of course with the limited frequency I can serve more number of users, but interference is more. So if I increase the cluster size, I can have more number of course capacity as well, but the number of frequencies used are more, carriers required are more. So the system capacity can be improved upon by frequency reuse. So that is called as a group of cells having a different frequency called as cluster. And here neighboring cells do not use the same frequencies in a cluster. The neighboring cells will be operating at different frequency. So basically what is cell? Cell is nothing but a small service area, small geographical area is called as smaller cell. Then here, instead of having a high power transmitter, we'll be going for a low power transmitter in the cells. So such that the whole area is covered. So by going in for frequency reuse, I can improve upon the capacity also. So frequency reuse is the being used in these clusters. So here you can see this same thing, 7-cell cluster is shown here. So this 7-cell cluster, 1, 2, 3, 4, 5, 6, 7 are operating in different frequencies. And this cluster, a group of cell, is repeated again. Because why this is required? Because we have a limited radio resource. We cannot have a separate frequency in each of these cells. And by going in for this available within the available frequency band, more number of carriers are being used, and it is repeated such that within the available radio resources, more number of users can be served. But at the when I'm going for frequency reuse, I should also consider the co-channel or interference. That is the basic, the main important parameter to be considered for repeating these frequencies. Otherwise, there will, if they are nearby, then there will be an interference from this cell to this cell. Whatever the user's signal gets interfered. So now we can see here by going in for more number of clusters and more number of channels can be calculated. So number of channels here, it will be equal to in total number. Suppose this is the area to be served, and how many number of users can be served. Number of channels that we can have is nothing but it is a product of M, K and N. M is nothing but the number of clusters. So here I have one cluster, second cluster, third cluster. So in each cluster I have cluster size is 7. So in each cluster I have 7 cells. And in each cell I have how many number of channels. Number of that is given by a parameter called as K. So by multiplying this number of clusters, cluster size, and number of channels per cell, I'll be able to find out what are the total number of users or total number of channels available in this area. So this is how the by going in for frequency reuse, we can improve upon the capacity and considering the interference also.